So let's start today video. It's regarding SRTM DEM digital elevation model. So in this video, I'm going to use elevation model to create the hillshade map, aspect map, and slope map, as well as the elevation from digital elevation model. So in this video, I'm going to use SRTM. Okay, so let's check SRTM. Okay, so uh, just click. So there is a different kind of elevation model is available over there. So look at this, the first one. Okay, it's a version number 4. It's a version 3003, and you'll find each and everything from over there. But in my case, I have used version number 3. Okay, just click. So this is the version number 3. So this data I have used for this tutorial. So the data provider is NASA, USGS, JPL Caltech, and data availability is from 2000. And this is the collection snippet, as well as the description is over there. The shuttle data topographic mission digital elevation data is international research effort that obtain digital elevation model on a rare global scale. Okay, so this is the 1 arc second, or approximately 30-meter resolution. Okay, so this is the user guide. So if you want to know more regarding this data set, how to use, then you can visit this website. This is the user guide, and this is the general document, and this is the algorithm theoretical basis document over there. So this is the basic documents over there, user guide. So this is the different kind of thing over there is like a dataset characteristics. Look at that, it's 1 arc second, 3 arc second, and 30 arc second over there, and how this data is created. Okay, this is the version number 1.0, and this is the version number 2.1, and then how this is created, you will find each and everything over there. Okay, and then this is the overview. So you'll find over there each and everything details over there, and this is also it's loading. So this is the basically the paper published in 2007 in review of geophysics article. It's basically AGU Advanced Earth and Science Space Sciences. It's a very reputed journal. So if you want to know, then you can download these data regarding this data from over there. It's an article. This is the and like if you want to citation, then this is the paper. This is the paper citation, and if you want to know, then you can visit. Okay, so this is the map, basically SRTM shaded relief topographic rendering on the Kamchatka Peninsula. Okay, how this is the space shuttle radar mission works, and the whole world map. Okay, this is the final coverage map of the C and X band system. They have used these two band, C band and X band, and this is the geometry and how SRTM swath were constructed. This is the diagram, and there is an algorithm, different kind of algorithm is available, and this is the hardware, and this is the payload bay, and how they collected data from the mission spectralist Garhard Trail and Jainath Kavandi go over the crew timeline in the shuttle at flight deck, something like that. Each and everything you will find in this paper. So if you are using this paper, then you need to cite sorry, if you are using this data, then you need to cite this this article. Okay, so let's go back to the tutorial video. And then band. So there is one band. Okay, so the name is elevation, description is also elevation. Minimum value is -10, maximum value is 6500, and resolution is 30 meter, unit in meter, and time is the these things, useless otherwise noted, something like that. So just close this one. So before close, you need to copy these things from collection snippet and close this one, and then just paste it over there. So before insert the data, let's visualize my study area. Okay, so in this case my study area is Kalimpong, so which is located in north of West Bengal. It's nearly Darjeeling. It's loading. Look at that. This is the basically shape file. Look at it is over there, red color. So close, and then the at first thing is you need to, I have center my study area, and the zoom size is 10. Okay, so you can increase or decrease as far as you need. And then load load this SRTM GL003 version data and clip this DEM data with my study area. So my study area is AOI. So Kalimpong is my study area, and I renamed it as AOI. And then visualization. For visualization purpose, I have used maximum value and minimum value and the color palette. Okay, so if you want to change the color palette, and then you can search G color palette. Okay, so you'll find everything over there. Which color you want to choose for your visualization purpose, and then simply, you know, so this is my DEM. So I want to visualize these things. So okay, so you can visualize map.add layer. DEM is my whole DEM, and DEM is my study area DEM, and this is for visualization purpose color palette, and renamed it as a DEM. Okay, renamed it as a DEM. And then so for visualization purpose, and after visualization, then we need to calculate terrain product. So using elevation model, digital elevation model, we here calculate terrain product like a slope and aspect. But for terrain, uh, so I calculated terrain. Okay, so this is the basic algorithm, e dot terrain dot product. So which product I am using? This is the DEM for my study area. Okay, so this is the basic thing for terrain product. So after calculate the terrain using this algorithm or using this code, then I need to calculate the slope. So slope is basically calculate using terrain dot select. Okay, so this terrain I am going to using, which I calculate from this DEM, and then select dot it rename as a slope. Okay, and similarly the same function, this is the only one line code. Using this only one line code, you can calculate the slope, and then similarly you have to write down the same code for calculation the aspect ratio. Okay, so terrain dot select and renamed it as a aspect, and both these two data, slope and aspect, is in degree. Okay, so if you want to know the more details like a GE code for terrain, uh, terrain using, so you can look at that. This is the things Google for developer. So how this is used. So calculate slope in degree from a terrain DEM, The local gradient is computed using 4 connected neighbor of each pixel. So missing value will occur around the edge of an image. Okay. So which algorithm you need to use? This is the basic simple code. ee.terrain.slope as input. Input means I have used the slope data. Okay. Input. And then similarly, this is the sample code, example code. You can copy it from over there and use for your study. So this is the basic code. Okay. And then for visualization purpose, the similar code you have to write down like a where slope visualization minimum and maximum value and the color palette. And similarly for slope map, and then visualization purpose for aspect. Okay, aspect is basically calculated 0 to 360 degree, so that is why it's 0 to 360. And color palette, so I have created it's a 1 2 3 4 classification, like a 0 degrees north, east and south, west and back to north. Okay, so this is the 5 classification. And then let's calculate the heel shade. Oh, one more thing, you have to add the layer for aspect for visualization purpose. Okay, and then the lastly is calculation the heel shade. So how heel shade is calculated? Okay, so this is the basic thing. You will find each and everything in Google developer website. Just you need to search like if I know calculate heel shade, calculate heel shade. Look at that, so you'll find it. Okay, how to create a slope, heel shade, each and everything. Okay. So simple code where heel shade equal to ee dot terrain and dot heel shade. So I want to calculate heel shade from the elevation. So elevation is digital elevation model, which I have this one. Okay, and then you need to add the layer. Okay, so like minimum value is 0 and maximum value is 255. In my case, you can change as per your need. So then add the layer. Okay. So optionally I have created overlay, so don't need to calculate these things. Okay, and then the final code is how to export the images. Okay, so I am going to export this image in my drive. So the simple code I need to write down export dot image dot to drive image as dim. So I need to export a digital elevation model in this case, and then description is dim srtm and folder is ge export, and file name prefix is dim srtm, and region is aoi and scale is 30, and crs. So in this case I have defined in crs 4326. It's basically if I don't know, just click over there. Sorry, CRS. Okay, so it's basically World Geodetic System 1984 used in GPS. Okay, you can find each and everything. Data is WGS 84. The full form is World Geodetic System 1984, and type is Geographic 2D CRS, Geographic Coordinate System, and coordinate is used latitude and longitude in degree, each and everything. Okay, and max pixel. And similarly, after writing the code for exporting DEM digital illusion model, and then you need to write the same code for exporting the slope as well as the aspect as well as the heel shade. Then just hit the run button. Okay, it will show. Look at that. So this is the visualization. So this is the visualization. Let's checks one by one. So this is the basically digital elevation model. Okay, digital elevation model. The color palette is over there. Some okay. it's basically high elevation and says basically low elevation. I have not added the symbology or legend over there. So this blue portion is showing the lower elevation model and this is the higher elevation. And then let's slope. Okay, so this is the basically slope. So this is the low slope and slope in degree. Okay, and then let's check the aspect map. So this is the basically aspect map. Okay, so this is the basically aspect map I have created. Okay, so it's looking very good. And then let's check Hillshade. So this is the basically Hillshade map. Okay, so as far as your need, you can change your start area using this code. I will share the code in the description box. So if you have any comment, then you can leave your comment in comment section. So this is the task manager. So look at that over there. This is the 4 file I have run for making this 4 file. So if you hit the run button, then you can export in your Google Drive and then create your map using ArcGIS or QGIS or any kind of GIS software. Okay, thank you very much.